And gentlemen, this is a tutorial on how to get water into the tube that will be used with the glass capillary that mounts the zebrafish. So what we're going to do is we're going to use this glass capillary to mount the zebrafish into the microscope when the zebrafish is suspended in agarose. So there are many different ways to try this, but I just want to note some things that don't work. So first, putting the glass capillary inside the water and sucking water into it doesn't work because you leave air inside the tube, and when you go to the microscope to try to push the zebrafish out, what will happen is the air will compress inside the tube, and because the agarose has a higher static coefficient of friction than kinetic coefficient of friction, the pressure will just keep building up until the force is enough inside the tube to push the agarose past that static coefficient of friction so that the agarose starts moving. But once the agarose starts moving, its friction goes down, which means the agarose will shoot out quickly. All that pent up pressure will just push the agarose out very rapidly. So we don't want to do that. Something else that doesn't work is putting the syringe under the faucet. So doing this does not get rid of the air bubbles. You will still have air bubbles in the tube. I don't know if you can see that, but there are air bubbles inside the tube. So what we will do to get rid of all the air bubbles and fill this with water, water being a non-compressible fluid which doesn't suffer the problem of building up pressure when we use the syringe. We will use a beaker with some water in it, just from the tap. We will put the capillary inside the water. Then we will put the syringe, or put the plunger in the syringe all the way and pull it out. And something very fascinating happens. Water starts to drain out, and you can kind of see it here. Water is dripping up from the end of the syringe. And it will keep doing this until the entire beaker is drained of water. Okay, so why is that? Well, the weight of water, the gravitational weight from this top portion here to the bottom here is greater than the weight of the water from this top portion here to the surface of the water. So the water on both sides of this bend have a certain gravitational weight, and because this weighs more, it will pull down all the water here, which will pull up the water here. So there's kind of a vacuum force that's vacuuming out this water from the beaker all the way to the end of the syringe. Now, because the beaker doesn't have any water bubbles in it, the beaker doesn't have any air bubbles in it. The water in the tube will not have any air bubbles. And so we can we can put the plunger inside the syringe about halfway. And now we have a tube with no air bubbles in it. Okay. Those drops of water are all on the outside. And we can use this tube, plunger, syringe, capillary. We can now use this to suck in the agarose at the end of the capillary with the zebrafish and mount it into the microscope. And from now on, the amount that the agarose moves will be directly proportional to the amount that we move the plunger inside the syringe, and it will respond very quickly and accurately. That's the end of this tutorial. Thanks.